Good afternoon, dear attendees. We invite your attention to a report on the topic, Research Activation Energy in Thermal Modification of Wood. Wood as a building material is widely used in construction and architecture due to its mechanical and operational properties. But under the influence of atmospheric factors, it is destroyed. Due to the fact that these materials are sensitive to moisture and biological damage, that is the ability to maintain functional properties under operating conditions. It is possible to increase the level of operation of facilities that use building structures made of wood. The essence of the method is to give the wood the ability to resist moisture, the spread of biodamage, which contributes to the destruction of wood and accelerate the destruction process. Given the above, the modification of wood difficulties for the application of technological schedules like time and temperature. This is primarily due to the fact that the structure and composition of wood are different and the modification process is not achieved, and the use of thermo-modified wood leads to its destruction. Therefore, the development of technological schedules for wood modification, research in thermophysics, the influence of structural features, this process is an unresolved component of ensuring the stability of building structures made of wood. So it is necessitate the establishment of a thermal modification mechanism for such materials. To establish the mechanism of thermal modification of wood chips, used samples of the wood as hornbeam, ash, pine. The weight of the sample was 190 mg. Thermogravimetric study of thermal degradation processes in dynamic mode using derivatograph Q1500D, heating rate 2.5 degrees per minute, a sample comparison, powder alpha corundum material crucibles, Lund sensitivity galvanometers. In the studied wood sample at temperatures from 75 to 100 degrees, endothermic processes take place, which are accompanied by a loss of up to 6% of their mass. The main increase in weight loss in the temperature range from 180 to 220 degrees occurred, due to the extractives of water and ethanol, as a result of polysaccharide degradation. Thus, the thermogravimetric parameters enable to determine the rate of thermal decomposition of the material at a given temperature and therefore show a qualitative assessment of the effects of heat. But more important task is to determine the activation energy thermooxidative degradation. Calculation of kinetic parameters TG curve, which satisfactorily describes the kinetics of decomposition of solids, based on the equation 1. The dependence of the specific decomposition rate of the material on temperature is described by the Arrhenius equation, which after mathematical processing of the TG curve, can be represented as equation 2. In this equation delta M, mass loss, %, at each temperature in the range of decomposition of the material. In figure shows a graphical dependence of the rate of destruction of wood on the inverse temperature. The value of the activation energy is calculated depending on 3. As we can see, pyrolysis of hardwood requires more activation energy, and therefore requires costs in its thermal modification, namely time and temperature. Thus, the calculation revealed that the thermal decomposition of pine wood requires much less activation energy than the decomposition of hornbeam and ash wood. The research results will also further signifies our strong resolve problems concerning the development of new means and methods of obtaining organic materials and operating conditions at different sites. Thanks for your attention.